Good day everyone. This code that I will explain demonstrates discrete time convolution using Python. It shows how convolution works manually and then verifies the result using NumPy's built-in convolution function while also visualizing the signals. First, we import NumPy, which is used for numerical operations such as arrays and convolution. Then we import matplotlib, which is used to plot and visualize discrete time signals. Here, x represents the input signal x of n, and h represents the impulse response of h of n of a system. These are discrete time sequences, not continuous signals. Manual convolution function. This function computes convolution step by step instead of using a built-in function. N is the length of the input signal. M is the length of the impulse response. The output length is n plus m minus 1, which is a fundamental rule of linear convolution. Y is initialized with zeros to store the result. Nested loops core of convolution. This section implements the mathematical convolution formula. Y of n is equal to the summation of x of k multiplied by h of n minus k. The outer loops goes through each output sample n. The inner loop multiplies overlapping samples of x and a shifted version of h. The condition ensures we stay within value indices. Each valid product is added to yn. Finally, the function returns the output signal y. Comparing manual and NumPy convolution. Y manual contains the result from our custom convolution. Y NumPy uses NumPy's optimized convolution. These two results should be identical, proving the manual method is correct. Creating time indices. These arrays define discrete time indices for plotting each signal properly. Plotting signals. A figure window is created with enough space for 3 plots. Plot 1. Input signal of x of n. This temp plot shows the input signal x of n, emphasizing that it is discrete time. Plot 2. Impulse response of h of n. This plot displays the impulse response of h of n, which characterizes the system. Plot 3. Convolution output of y of n. This final plot compares manual convolution result, NumPy convolution result. Since both overlap, it confirms that the manual convolution is implemented correctly. The layout is adjusted to avoid overlap, and the plots are displayed on the screen. In summary, this code demonstrates how discrete convolution works mathematically, implements convolution from scratch, validates the result using NumPy, and visualizes the input signal, impulse response, and output signal. This makes the code very useful for learning signal processing concepts, especially convolution.